Hello everyone, myself Subrata Shah, faculty of Dr. Sudhir Chandra Suri Institute of Technology and Sports Complex in Automobile Engineering Department. So today I am going to discuss about the topic of positive crankcase ventilation system. It is one of the component or mechanical device which can be used to reduce the hydrocarbon emissions effectively. How it is reduced? It is controlled, or it is recirculated the blow by gases which is stored in the crankcase. So this is the engine cylinder, and this is piston, and this portion where the crankcase is situated, that case is known as the crankcase. Gases are coming from cylinder or combustion chamber to the crankcase via the crevice volume. So crevice volume, what is crevice volume? Crevice volume is the volume in between the cylinder wall, piston and piston rings. Okay, what is blow by gases? The blow by gases is the phenomenon of leakage past of the piston and piston ring and the cylinder one, mainly by the crevice volume, and for the crevice volume from the cylinder combustion chamber or cylinder to the crankcase. And the blow-by of hydrocarbon emissions are near about the 20% of the total hydrocarbon emissions of the vehicle, and this is increased to about 35% if the ring are old or damaged. So in new conditions, if we are not installed any PCV system in a vehicle or an engine, that means it will generate near about 20% at the starting time of the engine and 35 to 40% at the old age of the engine. Okay. The blow-by rate is generally affected by the top land clearance and the position of the top ring, because some of the quenched gas is recycled in the combustion chamber, and the ability of this to burn will depends on nearness to the spark plug and the flame speed also, and it will burn only when favorable conditions are there. Otherwise it will be go with exhaust gases and creates the hydrocarbon emissions. Okay, so these are the blow by gases. Now how we control the blow by gases or blow by controls? The basic principle of all these crankcase blow by controls is recirculation of the vapor back to the intake air cleaners, and there are a large number of different systems in use, like positive crankcase ventilation. This is a system, and in the positive crankcase ventilation system, the draft tube, this is the draft tube, this draft tube is eliminated. This is the system without PCB, means we are not to circulate these blue by gases with the air intake, and this is the system with PCB, blow by gases controlled by with the PCB system, and this is not PCB, this is without PCB. So in that case the draft tube is used. This is the draft tube, okay, and this draft tube is eliminated in the PCB systems. The blow-by gases are consequently reintroduced into the combustion chamber, where they are burned along with the fresh incoming air and also fuel. And since the blow-by handling device places the crankcase under a slide vacuum, and they quickly known as a they're very quickly, and this system is called the positive crankcase ventilation system, okay. So there are also two types of positive crankcase ventilation system. You can see here the A and B. A is the open type positive crankcase ventilation system, and B is the closed type positive crankcase ventilation system. What is the difference? Here is the difference, that is in intake, okay. You can see the difference here. So now I'm going to discuss about the topic of open system. This figure A is showing the open type system, and it has a tube which leading from the crankcase or else the rocker arm cover through a flow control valve and into the intake manifold, and usually through an opening just below the carburetors, and it also provide the proper ventilation of the interior of the engine. Fresh air is usually drawn through the rocker arm cover, which is in opposite that containing the PCB systems. And in closed type system there is the PCB system has a tube which connected between the oil filled tube cap and the air cleaner. Both open and closed system function in the same manner as long as the PCB valve remains unplugged. And if the PCB valve plugs using an open system, the blow-by gases exhaust out of the oil filled tube cap and into the atmospheres. And with PCB valve plugged, it is no longer possible for fresh air crankshaft ventilation is occurred, okay. Now in closed PCB system, if the PCB valve is plugged, the blow-by is through the tube to the air cleaner and subsequently into the air horn of the carburetor. As you can see this figure, and there is no possible of escape of blow-by gases into the atmosphere even with the 100% PCB valve plugging, okay. And one more thing, with the PCB valve plug, the fresh air ventilation cannot take place, and the closed system however requires the engine to digest all blow-by all blow-by gases which are developed in the engine, and as well as the conditions of the PCB system. And the PCB valves located in between the crankcase and the intake manifold. Here you can see the control valve, which is control the flow of the crankcase blow by gases, which the amount of flow with that can be entered in the intake manifold. The design of the valve is such that at high speed and power and at low manifold vacuum, at the valve opens and allow a free flow of blow by gases to the intake system, and this is consistent with the high quantity of blow by gas which has to be transferred to the carburetor at high speeds. Okay, and the valve restricts the flow at the high manifold vacuum as the corresponding blow by gas is in small quantity. Okay, and this is the position of PCV valve, that is cruising position, and this is idling position. Okay, so in idling position the valve restricts the flow at a high manifold vacuum as the corresponding blow by gases is in small quantity. The air drawn for the ventilation of blow by gas has a very small tolerance, and a small amount of air will not affect any circulation, and too much air will lift the lubrication oil. Okay, so here is the crankcase. Okay, in crankcase we all know that there are lubricating oil are present there. Okay, if the valve or the suction pressure or vacuum is too much high, that what will happen? The lubricating oil which is present in the crankcase, that may be drawn with fresh air fuel mixture or the blow by gases that is mixed or coming out with the blow by gases. So if we resend this blow by gases into intake manifold with some lubricating oil, then what will happen? The emission doesn't reduce. The hydrocarbon emission, carbon monoxide emission will increase too much rather than decreasing. So you have to remember one thing, that is you have to design your valve so that the fuel air the blow by the lubricating oil cannot lift with the blow by gases, because we want to lift only the blow by gases, not lubricating oil. If lubricating oil is coming to this path and mix with the fresh air fuel mixture, that means the lubricating oil is also going to the combustion chamber for combustion, and your combustion performance is also decreased, and as well as the hydrocarbon carbon monoxide emission is also increased. Okay, so that's why we have to remember this thing before designing a PCV valve. Okay, and in this figure you can see, in this I will discuss this picture later. First of all, I am telling about the position of the PCV valve, and so the lifting of lubricating oil should be minimized. Okay, and also the carburetor has to modify that, adjust to amount of the amount for the change the change of change means change of air fuel mixture coming from the crankcase in order to the in order to the exact air fuel air ratios into the combustion chambers, and this should be monitored by the carburetor, that we have to provide the exact air fuel ratio that is demand by the engine. That is not like that the engine is demanding is rich air fuel mixture or lean in air fuel mixture or stoichiometric mixture, but carburetor is providing, there is no metering system of the blow by gases, and they are providing the you need lean mixture, but they are providing the rich mixture. So what will happen, the engine performance is also maybe decreased. So you have to design the carburetor so that the exact fuel air ratios be controlled. The carburetor deposits on the blow by gas metering valve will significantly affect the performance of the carburetor. So high grade motor oil has to be used, and in the closed ventilation system a provision is made for the blow by gases to escape to the atmosphere in case of the metering valve failure. So in the closed ventilation system there is a provision provision for the blow by gases to escape the atmosphere in the case of metering the valve failure. When the metering valve is failure, that means you cannot control the fuel air mixture ratios and also the lifting of the lubricating oil, that cannot be controlled. So in that case you have to release that blow by gases into the direct the atmosphere. Okay, so without PCB, that means that is without PCB system, means like that. Okay, there is no crankcase ventilation system. You can see here, this is the closed system from where from cylinder we are drawing or lifting these gases or exhaust gases and resent to it intake manifold. But without PCV system, that blow by gases can be directly sent back to the atmosphere. Why it is done? Because if we are not providing any release system, or we are not release that exhaust gases, the unburned gases inside the crankcase, that may be used or may be going back to the combustion chamber. And what will happen, that in suction stroke the cylinder is totally occupied, or the combustion chamber is totally occupied by the air fuel mixture or fresh mixture, and now during the compression stroke, the air fuel mixture which are present in the combustion chamber, that will compressed. And when it will compress, then what will happen, the gases inside this combustion chamber is passing through the crevice volume. What is crevice volume? As I told you earlier, that is the volume in between engine cylinder wall, piston and the piston ring, so that the gases are passing through that crevice volume and accumulate in the combustion in the crankcase system. So what will happen, after the combustion, the power is generated, my fuel chemical energy is converted into the mechanical energy, and this mechanical energy pushes that piston toward the BDC, and when it is moving from TDC to BDC, then inside gases, or the gases inside the crankcase will again occupied or trying to pass through this crevice volume and going to the combustion chamber, and it is mixed with the exhaust gases. When this unburned fuel or the unburned air fuel mixtures is mixed with the exhaust gases, that means it has it is the contents of the high hydrocarbon emissions. As I told earlier, that in a old engine that may be causes of 35 to 40% of the hydrocarbon emissions by these blow-by gases. Only blow-by gases can responsible for the 40% of the hydrocarbon emissions. So due to prevent such kind of hydrocarbon emissions, we was introduced that positive crankcase ventilation system and trying to lift or drawn that unburned gases or unburned mixture that is present in the crankcase. Okay, so this is the topic of crankcase ventilation system. Hopefully you enjoyed this lecture. Thank you.